Another option for our designs, in Plumber version 4, is to be able to evaluate the pumping equipment operating points in the case water is pumped directly against the network. So, to show you these features we will use the multifamily housing project that we already know, but with the particularity that, in this case, we have assumed that each building is made up of 11 levels. Thus, each riser, as you see in the respective tab, will have 11 delivery points. Each one of them supplies 4 standard water networks at each level of each building. In the isometric view of the riser's plan you can visualize this better. Observe the supplying scheme to these 4 risers. We have a tank from which a pumping group is fed which, in turn, supplies the network with pressure and flow directly. Let's go to the plan view, see their properties. We have assumed that the tank is underground, the most usual configuration, and, in response to this, we have specified, among other values, its minimum water elevation. This, as you know, is the most important parameter for most pumping system calculations. And, regarding the pumping group, we have in its properties, the suction from the underground tank located upstream, as well as its discharge directly against the network. Of course, in order to evaluate the operating parameters of a real pump in this system, we have created a pumping pipe, assigning it a centrifugal equipment from the database. In this case, we initially place the characteristic curve in the case where the pump's rotational speed is 1,100 revolutions per minute. Remember that, in order to have these pump models available here, we have previously gone to the Configuration tab. And, from the Devices panel, we have accessed the Pumps Manager. In order to be able to specify the values of the various operating curves of the models that we want to test in this project. Note that, using the tools in this administrator, we have generated the operating curves for the same model, except for the case where the speed is 1,300 revolutions per minute. Thus, closing here and performing the calculation and design by clicking the button on the Project tab, we can, in the case that no errors are detected, access the properties of the pumping group again. And, from the Calculation and Selection tab, have the necessary information to, on the one hand, make the equipment's broad selection. Here we will see that the system's required flow is about 33 liters per second, with a pressure or pumping head close to 51 meters of water column. On the other hand, we have the actual pumping system's operating information when a pump with the characteristics that we have previously specified through this model is used. And we see that, in the case that in this pumping station operates only one of this equipment, the maximum probable required flow by the system is not reached. Also, it seems that the deviation from the position of the best efficiency point is quite good. Therefore, we could consider studying the results when 2 of these equipment operate in parallel. That is, we will have 2 pumping pipes with the same characteristics in the pumping group. So, we change here to 2 and close the dialog by clicking OK to redo the calculation. When we return to the results, we find that this configuration allows to pump about 39 liters per second. But we have that the deviation from the point of best efficiency of each equipment in this condition is, maybe, too high to operate properly. Looking for a better solution, let's think that, without changing the model, we could consider testing it at a higher rotational speed. So let's go to the Pumping Pipes tab to create a new one. And assign the curve of this model at 1,300 revolutions per minute. Of course, for each new pumping pipe, it is important that you select the diameter of the pipes located upstream and downstream of each pump. Once changes have been made, we'll close this dialog again to redo the calculation. When we return to the results, we see a new row in the table of operating parameters with the new pumping pipe and pump added. We have then that, for this condition, it is possible to overcome the required flow rate by about 4 liters per second. And, still better, we see that the pump model is operating practically at the point of best efficiency, a much more desirable condition than for the first option. In this way you could continue studying the operation not only for other rotational speeds but, of course, for other pumps models. In a very simple way with PLUMBER.